we're going to do problem number 3 from chapter 3. Let me read the question first. A diver running 1.8 meters per second dives out horizontally from the edge of a vertical cliff and 3.0 seconds later reaches the water below. How high was the cliff and how far from its base did the diver hit the water? Okay, let's lay this picture out. Here is the cliff. You can see the cliff here. A diver is a person who's going to run off the cliff and dive into the water down below. So they're going to dive off and they're going to have some pattern that looks something like this. Okay, and they're going to hit the water over here. And they're going to dive off with a VOX in the VOX direction, in the X direction of 1.8 meters per second. And their questions are, how far did they land? How far is X? This is the X direction up here. And how high is the cliff, the mountain or cliff that they're diving off of? So Y is what? Those are the two questions that are asking. And they give us one more piece of information. They say the time to hit the water is 3.0 seconds. So they dive off the mountain and 3.0 seconds later they land in the water. The question is, how far did they go in the X direction and how high was the cliff? Let's look at the X direction first. We'll use the X equation of motion. X equals x naught plus v naught xt plus 1/2 a of xt squared. X naught, where they start from, is 0, and a of x is always 0 for horizontal flight and projectile motion questions. There's no acceleration in the X direction. So substituting these in here, we get x0 goes to 0, and we get ax goes to 0, leaving us only VOX times time. So x equals v naught x time, and we have those information from our graph, from our sketch, is 1.8 meters per second is how fast he dove off the cliff at 3 seconds before he hit the water. So multiplying them together, you get x equals 5.4 meters. So how far? X equals 5.4 meters in this direction from the edge of the cliff. So 5.4 meters is how far the person landed in the water. Now we look at the Y direction. We'll look at the Y direction next. Y equals y naught plus v naught y t plus 1/2 a of y t squared. Now y naught is also equals 0. V naught y is also equals 0 because when they jumped off the cliff, they only had an x velocity. They did not have a y velocity. So v naught y is 0, and ay is equal to the gravitational constant g. So now we get y naught is equal to 0, v naught t is 0, and leaves us only with this part of the equation left. Y equals 1/2 g t squared equals 1/2 g is 9.80 and t is 3.0 seconds, which was given, squared. And that gives us 44.1 meters. However, we have 3 significant figures here, but we only have 2 here, and we use the least amount or the smallest number of significant figures, so that would be reducing it y equals 44 meters. So if we go back to the original diagram, how high? Well, y is equal to 44 meters. So the cliff was 44 meters high, and he jumped out only 5.4 meters into the water.